we have been, Northern Dynamics have been working on a motion system for a client. As some of you may know, we do conversions from Rockwell to CODESYS, and we had a customer actually ask us to do a conversion that included motion as well. Now, the motion part of it's not there yet in the converting tool, so we converted the bulk of it, and then we're doing the motion side. But I guess I have a bit of experience in the motion control world, and some time back. We developed a motion control class and was involved in developing a motion control class, and one of the tools that came out of that was a cool little tool that I wanted to share with everybody. I wanted to share with everybody this tool that we use to allow you to sort of learn and test stuff on yourself by yourself on your computer, and of course CODESYS itself really lends to this well with the soft PLC built right into your computer. So let me share my screen here. Share. Do you want to? Yeah, I'm going to share, and I will share screen 2. It's a different resolution, and then close. Whoops, let me do that again. It's high-tech stuff, right? Share screen 2. You should see my screen now. Let me just move that out of the way. And great. So the tool itself, I've got it running. I've got it running in a soft PLC right now, and the premise I had when we started thinking about this was, how can we give students and people a tool that can allow them to play with motion control without having a motor, without having a servo drive, without having all this equipment initially, and of course it gives you a safe way of doing it. Motion control servo technology can have its challenges in the sense that you have things moving at high speeds and so on. So you have to be really careful with the equipment. So, anyways, this tool that I created, I'm leveraging the soft PLC. So this is running in your CODESYS, standard CODESYS soft PLC. And on top of it, what I use, instead of an actual drive per se, a physical drive, what I actually installed was a virtual drive. So the virtual drive allows us to play with a bunch of these instructions and build your project and go from there. So this is a really simple project using some of the standard MC based motion control instructions, and it'll allow you to actually see the position and velocity and so on. You can go through a lot of the instructions in our instruction set. Before we get too far, let me just quickly talk about that. When you get into the library manager, if you want to find your motion control instructions, there's two main areas: SM3 or SMC, which is the CODESYS based soft motion, and then of course you'll see in mine here it's using the MC base. So what I like to do, if I'm doing a new project and just want to add the library, you just add the library and go and search for, let's say, MC, and of course it's going to find all the instructions for you, and you can go from there. All right, so we're going to abort that. You would see that populate into the add library area, and then you could add the library and or whatever instructions, start using whatever instructions. So that's the initial start of finding the motion control instructions. From there, you just start building your axes, building your system to actually play with it. Of course, we put down a virtual drive off to the side here. We underneath the general axis pool, the soft motion pool, we put the virtual drive, and of course, it has all of the setup parameters that you would want in the case of a virtual drive anyways. Similar if you were, I'm going to show an example in a second of a real working axis. I have that also running in my office here, and you'll see that's very similar. But from there, the application is very simple. I've got the MC power, which basically enables and turns on your drive, gets your system locked and loaded. And then I have an absolute move where it's going to move to an absolute position, a physical position in space based on whatever velocity, XL and decel I set up, parameters. And then, of course, I've got read status to tell me if what condition it's doing, just watching how that works. And then the actual velocity, actual position, so we can see this. On top of it, I did create a trace. So I like to use a trace as well. Part of the CODESYS standard package is the trace utility. This gives us a tangible, what is the axis actually doing? You can watch it. Now, of course, Chris, your comment the other day was 100% correct. You can also use the virtual graphics that CODESYS provides. There's where you can actually create movement right on your screen and watch it move. So, I mean, that's also another option. So let me go and do this. This axis is all up and running. I'm going to hide the tree here, and I'm going to do this several times, and then we'll pull up the trace. I'm going to start off by turning on the axes. So I'll enable it, put the regulator on, start the drive, right click, and of course the axis is up and running. There's no errors in it. If you watch on your blocks, they'll have an error information that you can use. And then of course I'm going to go and put some parameters in the absolute move. So I'll start by just I'll put the parameters in first. So for example, I'm going to move to 100 units, and then I'm going to go at a velocity of 10 units. 10 units per second. And then, of course, the XL, I'll do 10 units per second squared. I'll do decel, 10 units per second squared. And then I'll leave the jerk parameter. I'll just leave that at 0. I'm going to right click those, put them in. And then what I'm going to do is quickly, I'm going to execute this, but I'm going to jump down and show you the position and the velocity moving. So let's take a look at this. So I'll double click this, write it, and quickly you'll see the axis is actually moving. The position's moving. The velocity is stuck at that maximum, or the velocity that it was set at, and then it's going to come back down. Okay, so you can see it's actually at position 100. Of course, this is an absolute position or an absolute move. So if I want to move it, I have to tell it to move to a new position. So I'm going to turn off the execute. I'm going to set the axis back to 0, and then I'll leave it at the same parameters, and I'll execute that again. Cool little tool, right? You can start playing with these instructions and it gives you a method of learning and testing and playing, and a very safe method. So from there, let me open up the trace now, just to show you that as well, because that's always cool to actually see. I'm going to put them side by side in my CODESYS window here. And then of course, I'm going to execute the same thing. You have to download the trace, and the trace will start moving, as you can see in the screen. So I'm going to set it back to 100 again. Let's go back to 100. And I'm going to turn off the execute. I have to turn off the execute as well. So, and then I'll re-execute it, and you'll see it actually start. You can see the trace is starting to move there. So it gives you representation of velocity, the actual velocity at 10, and then the position it reaches 100 and comes decels back down. So now you can start playing with all these XL decels. You can start playing with the jerk condition and so on. You can start playing with all these things and see your axis moving right in the trace. So that's, to me, this is a fantastic tool to give you that. So let's start the trace again, and then I'll do one more time. I'll execute this, turn off the execute. I'll set it back to 0, and then of course right, and I'm going to execute, and you'll see it goes back down to position. So of course, um, um, this tool that I've got here, this application, I have distributed before, and I don't have any problem redistributing it. If you're interested in actually getting this without having to build one yourself, you're more than welcome to email me at this address, and I can send that to you. Secondly, I've got an open application with an actual axis. So of course I've got, sorry, it's not under the soft motion. It's actually under the actual axis, is actually under my EtherCAT master. So this is, so Northern Dynamics represents a company, Italian company called CMZ, and they make controllers, they make PLC controllers, they make servos, and they make servo motors and so on. They're the complete package, and we represent them in Canada here. And that's what we're seeing. That's what you're seeing here. It's a CMZ EtherCAT module, and of course the axis underneath. And it's no different than what we just saw in the soft motion. What we can do is you can literally just write the you go and you can write the axes. Right, in that case I did reset. I'm going to turn on the power, write all, the axis is on, and then of course I can, in this case I have a home instruction. So I don't know if you can see it, right around here is the actual position. I'm going to trigger the home. I'm going to trigger home so that we can actually see it go home. And it's a one-time write to home, so you can see it's now home. And then of course what I can do is, in this case I decided to use a relative move. So I've already got parameters in here, and actually what I've got is a double move, one move feeding into the other, one relative move feeding into the other, just as a test. And so if I trigger that, you can see the axis is moving. It's going to move to 100 first, and then it'll go at a slower speed, 5. It'll go down, should go down to 5. Yeah, it's going down to 5, and then it's going to go to 150 as its position. And again, let me turn that off. Sorry, not that. Let me turn this off. There. I'm going to home it again, and then this time I'm going to pop up just like I did in the soft motion version. I'm going to call up the trace and hide the tree. I'm going to turn off the device, and I'm going to put it so I can see both, and download the trace. The trace is running. So again, if I go and hit move, if I go and actually hit the move, you can see it's going to start to run. You'll see it go up to 100, and then of course there's a secondary move up to 150, and that's at a slower velocity. So again, you'll see the lower velocity in the trace, and it goes up to position. Simple as that. So these are definitely tools that the first one is a tool that you can use on your own desktop just to play with. If you have an actual axis that you can also play with at your office, this is another example of that.